Hello there, welcome to CSEC Math TV. Today we're going to be looking at coordinate geometry, and these are the topics in coordinate geometry: gradient of a line, equation of a straight line, parallel and perpendicular lines, length of a line, midpoint of a line. Now unfortunately the PowerPoint is not working right now, and so we won't be able to use the animation effects. Alright, so the notes are going to be there and we're just going to go through it together. So the first thing is, with coordinate geometry, right, we have points. Usually you're going to see points on our Cartesian plane, right? Now the vertical axis is known as the y-axis and the horizontal axis is known as the x-axis. The coordinates are usually put as a pair, your x coordinate, your y coordinate. Now the x coordinate tells us the horizontal distance from the y-axis, and the y-coordinate tells us the vertical distance from the x-axis. For example, if I were to tell you that the x value here is 1, the y value here is 5, and this is the point, let's call it R. In this case, we'd say that the coordinate of R is 1, 5. That's all. Alright, we're just saying that, see it here, the x-coordinate tells us the distance, horizontal distance, so unit 1 from the vertical axis, and then the y-coordinate tells us the vertical distance from the x-axis. Alright, that's all we're saying. Now, typically now, oftentimes, they're going to ask, a lot of time they're going to give you 2 points and ask you to find the distance between those 2 points. We're going to have to use what we call length of a line formula. Now the length of a line formula, no, you're not seeing it. The length of a line formula is given by the square root of x2 minus x1 square plus y2 minus y1 square. This is the formula we use to find length of a line. So given any 2 points, you want to find the distance between them, this is the formula we use. Now it doesn't matter which one you call your x2, your y2, your x1 and your y1. So for example, right here, right, we get this right here, right? We get the 2 points, M and N, and they say find the distance between the 2 points. First thing I want you to do is write down the length of the line formula. So the length of the line, MN, the formula we know is the square root of x2 minus x1 square plus y2 minus y1 square. Now you are then going to determine which one you want to call your first point and which one you want to call your second point. I'm going to call this my first point. So this is x1, y1. And down here is x2, y2. So in that case now, the distance L, the distance from M to N is the square root of So this now is the square root of your x2 is what? x2 is 3, so 3 minus 4 square plus y2, which is negative 5, minus 7 square. So in that case, it's going to be 3 minus 4 square, that is negative 1, and negative 1 square is 1, plus negative 5 minus 7 is negative 12, and we're squaring that. So just in case you want to see it, the full working, then you can put that into your calculator. You can put it into your calculator, square root negative 1 square plus negative 12 square. In that case, you get your 12.04 right here. So the distance between M and N is 12.04 units. So another one, right? What is the distance between A and B, right? To find the distance between A and B, as I said, the animation would have let this pop in afterwards. I was just calling this point my x1, y1, and this point my x2, y2. But just for the fun of it, what if you decided to call this one your x2, y2, and this your x1, y1? It doesn't matter, I'm just showing you. So then the distance from A to B, or the length of the line A to B, that's now the square root of, x2, 5, minus x1, negative 4, square, plus y2, negative 1, minus 5, square. This works out to be 5 minus negative 4 is 9, so that's 9 square, plus this is now negative 6 square. That would work out to be 81 plus 36, and then you square root it. You put that in a calculator, the square root of 81 plus 36, get you 10.81 or 10.82, right? And that is it. So the length of the line, or the distance from A to B, is 10.81 units. Now, again, ignore how trashy the notes is looking. My apologies. It's looking this trashy because it's really meant to be in PowerPoint, but as you can see, the PowerPoint froze. I can't even close it. Right? So the PowerPoint froze, guys, and we can't even write on it. We can't do anything. Now, let's get back to what we were saying. Next thing is to look at the middle of the line, known as the midpoint of a line. So ignore all of this. It didn't come out good because it's really a PowerPoint I'm opening as a PDF. So to find the middle of the line, how do we go about finding the middle of the line? The middle of the line right here, anytime you're given the two endpoints and you want to find the middle of the line, to find the midpoint, we find the average of the x values, so x1 plus x2 divided by 2, comma, then y1 plus y2 divided by 2. This is how we find this point. So the average of the x values and the average of the y values give you the midpoint. That is all. Example, we need to find the midpoint of this line, right? In this case now, you average the x values. So notice we're going to add 3. We're going to add 3 and 4. So notice that's what we did here. So midpoint of MN, we add x1 and x2. So add 3 and 4 to give us 7. 7 divided by 2 is 7 over 2. Next thing, you're going to average the y value. So 7 plus negative 5. So add 7 and negative 5. That's negative 5 plus 7, which is 2. And 2 divided by 2 is 1. So in that case, the y value at the midpoint is 1. Easy. Now, oftentimes now, they're not going to give you questions so straightforward. They might give you, ignore all of this. I'm going to put it up again. Ignore that part. Now, read the question at the top. It says the midpoint of the line segment joining negative 3, 4 to the point P is 1 minus 2. Find the coordinates of P. So in a case like this, I want you to picture what they're saying. If you draw a line, look at the top of the screen, you draw a line. They told us we have this point right here, which is negative 3, 4. That's this point. And they told us that the midpoint of the line, so this point right here, they told us the midpoint of the line is 1 minus 2. So that is 1 minus 2. Then they're asking us to find out now what this endpoint is, which is P. Now, what do we know? Since this is the middle, what we do know is that let's call the point PAB, right? If we call that AB, what we do know then is 1 is the x value in the middle. So we know that 1 would be equal to the x value in the middle. So let me set it up properly. Follow what I'm doing. Let me set it up properly. Right? So setting it up properly, we're saying that 1, negative 2, to get the midpoint, it's equal to, remember it is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So in that case, we're saying 1, negative 2 is equal to x1 plus x2, so it's negative 3 plus a divided by 2, comma, the y value is 4 plus b divided by 2. So in that case, we can do what? We can equate the x coordinates. That's how we get this equation. Then we can equate the y coordinates. That's how we get this equation down here now. From that, we solve for a and b. So solving for a and b, cross multiply and get our a is 5. Cross multiply and solve for b, b is negative 8. So P is the point, 5, negative 8. And we'll see how the concepts of midpoint of a line was used to do this question. No problem. The next thing is finding gradient of a line. This is very important. How to find gradient of a line. Now, anytime you're given a line, all right, this is what the gradient is, what we call the slope of the line. And the slope gives us the change in y over the change in x. The slope gives us the change in y over the change in x. So in order to do that, what we do is we draw a little triangle like this. We'll find the difference in the two y values, and we take the difference in the two x values. That number we get is called our gradient. The gradient is often denoted by the letter m, right? That is it. So for example, we have these 2 points here, 4, 7, 3 minus 5. First thing is decide which point is your first point. So you can call that your x1 and your y1. Let's say you call this your first point. So up here would be your x1 and your y1, x2 and your y2. So in that case, the formula we just said for gradient is y2 minus y1 over x2 minus x1. So in that case, y2 is negative 5 minus 7 divided by x2, 3 minus 4. That works out to be negative 12 divided by negative 1, which is 12. So that's how we get the gradient of the line is 12. So we're saying the slope of this line is 12. That's all we're saying. Easy. Now look at this. It doesn't matter which one you wanted. If you had called this one around here your x2, y2, and this one your x1, y1, notice you get the same answer. 7 minus 5 is 12. 4 minus 3 is still 1. It doesn't matter. So whether you doesn't matter which point you call it x1, y1, you're still getting, whether you put negative 5 minus 7 over 3 minus 4, or you put 7 minus negative 5 over 4 minus 3, still get 12. Doesn't matter the order. The next thing now, which is extremely important, is the equation of a line. Now the equation of a line is in the form y equal to mx plus c. You must know this. I'm going to put a box around this. You must know this. M tells you the gradient of the line, and we know to find M already. Remember, M is y2 minus y1 over x2 minus x1. Then now C is the y-axis intercept. C tells us where the graph cuts the y-axis. C tells us the point where the line cuts the y-axis. So the y-intercept and the x value at that point is 0. So for example, the line y equals 3x plus 4, they're telling us that the y-intercept is 0, 4, and the gradient is positive 3. That's all they're saying. Right? Now, oftentimes they're going to give you the question worded in two ways. Either they give you 1 point on the line and the gradient, or they give you 2 points. And they're going to ask you to determine the equation of the line. We know the one equation we're using, y is mx plus c. Everyone knows that. Now, either it's going to come where you do it using method 1 or you do it using method 2. In method 1, when they give you a point and the gradient, they already give you m, you're just trying to find c. Example, they say a line passes through 0, negative 4 and has a gradient of, let's say they say the gradient was 2. And they say, what is the equation of the line? In that case now, so ignore all of this down here. In that case now, using y equal mx plus c with m being what? 2, because they told us the gradient is 2. The equation of the line would be y equal 2x plus c, and c is negative 4, so you just write minus 4. Don't put plus negative 4, just put minus 4. Now, sometimes it's not so straightforward, so sometimes it's given this way. Suppose we are given the gradient of the line, but not the y-intercept. For example, let's say a line passes through the point 2, 5 and has a gradient of 2. What's the equation of the line? In this case now, what did they give you? They gave you the gradient. The gradient is what? M. They gave you M. So what do we know? What we do know, this is one way to do it. I'm not going to do it how I did it in the notes. I'm feeling to do it a different way. Since I gave you the gradient is 2 and you know the equation of the line is y equal mx plus c, what do you know? You know a y value is 5, you know a x value is 2, and you know the gradient. We can use that to find c. So in that case, put the y value is 5 equal the gradient is 2, the x value is 2 plus c. 2 times 2 is 4 plus c is 5. And so c must just be 1. Now since c is 1, then the equation of the line is y equal, the gradient we said was 2x plus the c value we get was 1. This will be the equation of the line. Always work. Now I did it another way right here. You could do it this method, but I'm not showing it that method today, right? So it still works out to be y equal 2x plus 1. I'll show that. You know what? I'll explain it after I tell you the formula. So the general case now, this is another way to finding equation of a line. I didn't want to get into it because sometimes this one is usually complicated. This is another way of finding equation of a line. We use the equation y minus y1 or yp equal gradient in bracket x minus xp, where yp and xp are known points on the line. That's it. Right? So again, you just need to know this. The equation of a line through a point with gradient n is y minus y1 equal gradient in bracket x minus x1. So for example, look at this. They tell us a line passes through 3, -2 and 5, 4. Write the equation of the line. So can I copy this? Yes. So look what I'm going to do. I'm going to copy it and do it on a blank screen. There's a reason why I don't want to. I want to do it the two methods around here. So that's why I'm going to the blank screen. So let me just paste it here. We're going to do it the two ways. So let me separate the page, right? So method 1 and method 2. Method 1 was what? We said the equation of a line is y equal to mx plus c. In this case now, first thing, find the gradient. The gradient is y2 minus y1 over x2 minus x1. So in that case, this depends which one you want to call your y2, your y1, your x2, and your x1. In this case, this is your x1, this is your x2, this is your y1, this is your y2. So in this case, it's now 4 minus -2 over 3 minus 5. 4 minus -2 is 6, so that's 6 divided by 3 minus 5 is -2. 6 over -2 is minus 3. In that case now, since the gradient is minus 3, we just need to find our y-intercept. So since we need to find our y-intercept now, what do we know? We know that when we can use any point. I'm going to use a positive point. When x is 5, the y value is 4. So in that case, we can put y as 5. The gradient we just found is -3. The x value is 5. Oh, sorry, the y value was 4, I mean. The y value is 4. The gradient is -3. The x value is 5 plus c. We can use that to find c now because 4 is -15 plus c. Bring it over, so 4 plus 15 equals c, so c equals 19. So in that case, we get the equation of the line then is y is equal to the gradient -3x plus 19. This is the answer. Now method 2 is my preferred choice. You'd say y minus the y value given equal gradient in bracket x minus the x value at the point given. Now it doesn't even matter which point you use. Let's use the other point. We already know the gradient is -3. So it's y minus the y value at this point is -2. Y minus -2 equal the gradient -3 in bracket x minus the x value given at that point, which is +3. So in that case, it becomes y plus 2 equal negative 3 times x is negative 3x when you expand into the bracket, and negative 3 times negative 3 is positive 9. In that case now, we're expanding, so we subtract 2 from both sides, and that would be giving us subtract 2, negative 3x, subtract 2, we get plus 7. And this would be the equation of the line. Now clearly we went off somewhere. Let's see what happened. Alright, so I pasted the question and we're going to do it the two different ways. So method 1 and method 2. With method 1, we're going to use the formula y equal to mx plus c. With method 2, we're going to use y minus yp equal gradient in bracket x minus xp. In this first example, right, you're required to find a gradient and the y-intercept. The gradient is y2 minus y1 over x2 minus x1. Let's say this is our x2 and y2. So it would be y2 4 minus y1 negative 2 over x2, and x2 is 5 minus x1. So that is 6 over 2, which is 3. So the gradient is positive 3. Then we need to find c. To find c, we use that point. At the point 5, 4, what do we know? We know the x value is 5 and the y value is 4. And remember the equation of the line is y equal mx plus c. So then the y value is 4, the gradient we just found is 3, the x value is 5, and we have plus c. So this is 4, 3 times 5 is 15, and 4 minus 15 then would give you c. 4 minus 15 is negative 11, so that's c. So the equation then is m, which is 3x plus c, and c is minus 11. This is our answer using method 1. Method 2 now is using that same point you just said, y minus the y value at the point 4 equal the gradient 3 in bracket x minus x value at the point 5. Y minus 4 is equal to expanding the bracket, that's 3x minus 3 times 5 is 15, add 4 to both sides, y is 3x, add 4 and add 4, that's minus 11. Now the beauty is that you didn't even need to use this point, you could have used the other point as well. So even another alternate, you could have said y minus the y value down here minus 2 equal gradient 3 in bracket x minus the x value up here, which is 3. This works out to be y plus 2 equals 3x minus 9. Then subtract 2 from both sides. When you subtract 2, it would be minus 9 minus 2. So y is 3x minus 11 still. So it doesn't matter which one of the points you decide to use, right? It doesn't matter. So either way, you can choose which one you want to use. So that's what I wanted to show you. So in the example here, I decided to use the second method, I believe, this way. Alright, so we got the equation of this line. Now, oftentimes, one more way to give the equation of a line is to put it in the form ax plus by plus c equal to 0. Right? Now, the example here is often confusing. Alright, so I'm just going to make up an example around here. So around here, this is another way of expressing a line. A line can be expressed in the form ax plus by plus c equal to 0. So example, let's say I gave you the line y equal to 1 over 5x plus 7. To get it in the form that we need, first thing you'd need to do is you multiply the equation through by 5. Why? You need to get rid of the fraction. Your aim is always to get rid of the fraction. So you get 5y is equal to 5 times 1 over 5 is just 1, so that's 1x. 5 times 7 is 35. You then bring everything to one side, so you'd bring over the 5y, come over here, so 0 is equal to x minus 5y plus 35. In that case, you can interchange the left side and the right side. It is the same thing. So in that case, our A would be positive 1, or B would be negative 5, and our C is 35, right? That's if we rewrote the line in this form, right? So this is the general form of a line. This is the standard form of a line. So remember, let me separate it here. Y equal mx plus c. This is the standard form. This is the standard form. Always remember that is standard form. Then now, ax plus by plus c equal to 0. This is the general form. This is the general form of a line. General form. Alright? Now, next thing to talk about is what we call parallel lines. Now, if two lines are parallel, what happens is that they have the same gradient. Think about it, right? If you look at parallel parking, right? If you're traveling, right, you notice parking the vehicle, what happened? Parallel parking, they're going in the what? Same direction, right? Parallel. So this park is parallel to that park. Parallel, right? Now, two lines are then parallel if what? They're going in the same direction. And if they're going in the same direction, their gradients will happen to be the same. So, how do they ask the question? When they ask questions like this, show that the lines 3y plus 6x equal 2 and y equal negative 2x plus 7 are parallel. You just need to remember that parallel lines have same gradient. Parallel lines have what? Same gradient. So in that case, the only way to do this is to show that both lines will have a gradient of negative 2. Because the second line is already in, it's already in what? It's already in standard form. In standard form, you're able to identify your gradient, y equal mx plus c, so the gradient is negative 2. So we need to rearrange the equation of the first line in standard form to get the gradient. So first we can bring over the 6x. That's what we did to get 3y is negative 6x plus 3. We then divide both sides by 3 here. And by dividing both sides by 3, 3 cancel 3. Negative 6x over 3 is negative 2x. Then 2 over 3 is just 2 over 3. In that case, we saw that the gradient is also negative 2. The gradient is negative 2 for both lines, and so they're parallel. That's all we do. Two parallel lines have what? Same gradient. Next bit of information we must know is perpendicular lines. I made sure to get a graph to show you what's happening. If I gave you a graph, look at the line in blue and look at the line in red. Notice that those two lines, they do what? They intersect at a right angle. Since they intersect at a right angle, we observe something very special. This is 90 degrees, 90 degrees. Alright, something special happens. By the way, the line in red, this is the line y equal x. The line in blue right here is y equal negative x plus 2. I know we could have found the equation ourselves, but they gave it to us. I want you to observe something really spectacular about these two lines. For the line up here, y equal x plus 0, because the y-intercept is 0. In this case, the gradient of this line up here is just 1. The gradient of the line in blue down here is negative 1. Notice the coefficient of the x is 1. The coefficient of the x here is negative 1. So notice the gradient of here is 1 and the gradient of here is negative 1. So what's our conclusion? If the gradients of two lines have a product of negative 1, then they're perpendicular. Notice when you multiplied 1 times negative 1, you get negative 1. So if you multiply the gradient of two lines and you get negative 1, then the two lines are perpendicular. Let me write that down for you in a statement, because I know sometimes seeing it so much in words, it's confusing. So I'll write it down in a statement. If two lines L1 and L2 are perpendicular, this symbol means perpendicular, then M1 times M2 is equal to negative 1. This is what you need to know. That is the product of their gradients is -1. That's it. If two lines are perpendicular, then the product of their gradients is -1. So in this case now, right, in general, if the gradient of a line is m, then the gradient of the perpendicular line to it is, this in this case would be -1 over m. Alright? How? Because when we multiply the two of them, we should get -1. M times -1 over m, that would give us -1. So if you know the gradient of one line, and you know another line which is perpendicular to it, when you multiply the two gradients, it should be getting -1. So here's an example here. It says, find the equation of the perpendicular bisector of the line joining -2, 2 and b, which is 4, 1. So I'm going to copy this and we're going to do it somewhere separate. Ignore the little mark in there. We're going to go to the blank screen. So in this case now, right, finding the equation of the perpendicular bisector. First thing is I want you to visualize what is happening. We have a line. They give us the endpoints. The endpoints are 4, -1, and -2, 2. These are our endpoints. This is your point A and your point B. Now, what do you know about perpendicular bisector? Perpendicular bisector means the line is perpendicular to it. So this is the line they want us to find. Bisector means it also cuts it in half. So this distance equals this distance. Now if it cuts it in half, then the bisector must also pass through the midpoint. So the line must pass through the midpoint. So let's call this bisector line, let's call it L. So what do we know? First thing we know is that L is perpendicular to the line AB. L must be perpendicular to the line AB. Let's call it L1. So L1 must be perpendicular to AB. So first thing we need to find is the gradient of the line AB. Now the gradient of the line AB is y2 minus y1 over x2 minus x1. We do that and we get -3 over -1 minus 2. -1 minus 2 is -3 over 4 minus -2 is +6. The gradient is -1/2. Now, what do we know then? Let's call the gradient of L1, let's call it m. So we know that m times -1/2 should be equal to -1. So therefore, we divide both sides by -1/2. So now we get the gradient of that line is going to be your 2, +2. -1 divided by -1/2. If you don't believe it, you put in the calculator. -1 divided by -1/2, you get your +2. Now that we get our +2, right? Now we can find the equation of the bisector. But first thing is we need to find a point that the bisector passed through. The point it passed through is the midpoint of the line. That's why it's called bisector. Bisect means split in middle. So in this case, this point, we need to find the midpoint. Now the midpoint of AB, remember it's average of the x, average of the y. So -2 plus 4 divided by 2, comma, 2 plus -1 divided by 2. That works out to be 2 over 2 is 1. 2 plus -1 is 1/2. 2 plus -1 is 1. 1 over 2 is 1/2. So the midpoint is 1/2. So in that case now, we have the gradient and we have the point. So now we can use the equation of the line y equal mx plus c to find c. Now the y value we know is 1/2 equal 2 times the x value we know is 1 plus c. So from that, y, well, find c first for me, please. I didn't even find c. So finding c first, we realize that c is going to be, bring over the 2. So c is 1/2 minus 2, which is, I think that's -3 over 2. So now we get the equation of our line. The equation of our line is y is equal to 2x minus 3 over 2. This would be your answer. That's the equation of the perpendicular bisector. If you wanted to make it prettier, you could write, this is in standard form. Remember, this is standard form. You could put it in general form by multiplying through by the fraction 2 to say 2y is 4x minus 3. Then bring over the 2y to say it is 4x minus 2y minus 3 equal to 0. This is the general form, right? So if you gave your answer in either of these forms, that's okay. Alright, so notice they gave it in the general form, right? They gave it in the general form, just like we had. Right. Alright, now sometimes you're going to have to learn how to sketch the graph. So suppose we want to sketch the straight line with equation 2y plus 3x minus 12 equal to 0. We're going to learn how to sketch a graph now. Now, we're going to do a couple. Now let's do this one right here. So let me write it down because it looks messy around there. So it is 2y plus 3x minus 12 equal to 0. Now in this case it's in the general form. There's two ways I would always suggest to do it. You can always put it in the standard form to find the y-intercept, but when you're sketching a graph, there's two things you need. You need to know the x-intercept and you need to know the y-intercept. So for a sketch, we need to find the x-intercept. To find the x-intercept, this is always the point where y is equal to 0. Think about it. On a graph, the x-intercept, this is your x-intercept. Let me draw it a little bit better. This is your x-intercept. Your x-intercept is right here. This is your x-intercept. Now, on the x-intercept, what do we know? We know that the y value is 0. On the x-intercept, we know that the y value is 0. And on the y-intercept, we know that the x value right here is 0. Because on the y-axis, all the x values are 0. So this would be y-intercept. This is x-intercept. So in that case now, we need to go ahead now and of course, let's use that now to find our x-intercept. So finding our x-intercept, the y value is 0. So put 0 here. This is 2 times 0 plus 3x minus 12 equals 0. From that we're getting 3x minus 12 is 0. Bring over the 12, we get 3x is equal to 12. And so x must be 4 because 3 times 4 is 12. And so the x-intercept is 4, 0. Now once we get the x-intercept is 4, 0, we need to find our y-intercept. Now we need to find our y-intercept, and the y-intercept, this occurs when x is equal to 0. And so now when x is 0, we plug 0 up here. So this is 2y plus 3 times 0 minus 12. And so in that case now we're getting 2y minus 12 equals 0. And so 2y is equal to 12. So y is 6. In that case, the y-intercept is the point, x is 0, the y value is 6. Now you can sketch your graph. To sketch your graph now, remember, all you're going to do now is you're just gonna put on your x-intercept first, then put on your y-intercept. This is your y-axis, this is your x-axis. Your x-intercept is the point 4, 0. So the x value is 4 and the y value is 0. And then the y value is, for your y-intercept, the x value is 0 and your y value is 6, somewhere up here. Then now you're going to draw a straight line passing through your x-intercept and your y-intercept, like this. That's it. And this would be a sketch of your graph. This is a sketch of the graph. Now, What was the graph again? 2y plus 3x minus 12 equals 0. That's your graph. Easy. So if you go back and look what they had, that is definitely what they had. There it is. You just find the x-axis, the x-intercept, your y-intercept, draw a straight line passing through two of those points, and that's it. So here's another question now. They tell us that the line L1 in the following diagram has equation 3x minus 4y plus 6 equals 0. They tell you the line L2 is perpendicular to L1 and passes through the point 2, 4. They say the lines L1 and L2 cross the x-axis at A and B. Find the equation of the line L2. So the line given in purple is L2. The line in blue is L1. So now we need to find the equation of L2 and then find the length of AB. So pause the video and attempt this question for me, please. So let's go ahead and find L2 first. I hope you have attempted the question. If you don't, go ahead and pause the video, please. You have to do the question first. Now, to do this question, they told us that L1 is perpendicular to L2. So the first thing you have to do is rewrite the equation of L1 in standard form. So if we bring it over, this is saying 3x plus 6 is equal to 4y. So if I bring over, in other words, the equation is 4y is 3x plus 6. In other words, if we divide both sides by 4, then the line is y is equal to 3 over 4x plus 6 over 4. So L1 is really 3 over 4x plus 6 over 4. That's the equation of L1. So that means the gradient of L1, the gradient then, what's the gradient of the first line? 3 over 4. If the gradient of the first line is 3 over 4, we can find the gradient of the second line. So for part A, we can tell them the gradient of the second line. The gradient of the second line is negative 1 over the gradient of the first line. That's the only way when you multiply the two gradients, you get negative 1. So in that case, the gradient of the second line is going to be negative 4 over 3. Think about it. Let me show you in the calculator. 3/4 multiplied by negative 4 over 3. That will give you negative 1. So the second line has gradient, L2 has gradient, negative 4 over 3. The next thing they told us was that the second line passed through this point, 2, 4. So now remember the equation of a line is what? Y equal to mx plus c. Now we know the y value is 4, and that's equal to the gradient, negative 4 over 3, times the x value. The x value given is 2 plus c. So negative 4 over 3 times 2 is negative 8 over 3. So when we bring it to the other side, it becomes 4 plus 8 over 3 is c. So in that case now, we can add 4 plus 8 over 3. That gives you c. And so c is 20 over 3. C equal 20 over 3. So now you can write down the equation of L2. So for part A, the equation of L2, so I'm just going to put it here since I don't have much space. L2 has equation y equal to negative 4 over 3x plus 20 over 3. Or you can rephrase it by multiplying through by 3 and write 3y equal negative 4x plus 20. Or some persons might rewrite it. So just to rewrite the final answer one last way, you can say L2 is, bring it over here to say 4x plus 3y minus 20 equals 0. If we bring everything to the left side, it becomes plus 4x and minus 20 on the other side. So you can write the answer this way, right? So this is your answer for part A. So part A, right there. Now the second part is find the length of AB. So you need to find coordinates A and B. What is A? A is the x-intercept. What do we know about x-intercept? The y value is 0. So if the y value is 0, you put 0 right here. If you put 0 right here, this is 3x plus 6 is 0. And if 3x plus 6 equals 0, then that means x is negative 2. So A is the point negative 2. Now for B, you're going to put what? Put the y value as 0. If you put the y value as 0 right here, this is saying 0 equals negative 4x plus 20. So 4x is 20, so x must be 5. Now the distance between negative 2 to 5 is positive 7. Right? You don't need to use any formula for that. To go from negative 2 to positive 5 on a number line, the distance is 7 units. So that's part B. Part B answer is 7 units. Now let's see how I did it in the notes when I was doing it, because the notes I may have done it a little bit different. Nope, did it the same way. So 4x plus 3y minus 20. Final answer like what we just did. Then now let's see how I did A and B. Yep, same way I did it using the x-intercept to get A and B, and then taking the difference to get the same 7. Easy. Alright, so this is question number 2. It says on the graph, it has the point P marked, and it says write down the coordinates of P, and then through P, draw a straight line whose y-axis intercept is 4. So we're going to do this question. So in doing this question, right, first thing is write down the coordinates of P. So P, as we realize, P right here, the x value is 5, the y value is negative 2. So P is the point 5, negative 2. So that's P, 5, negative 2. Now you need to draw the y-intercept is 4. So that means that it passes through the point where the y value is 4. That's the y-intercept, where the graph intersects the y-axis. So we are just going to draw a straight line connecting this right here. That's it. Easy. What else they ask? Then now after we draw that straight line, they ask us to calculate the gradient of this line. Right? So that's the next question. We need to calculate the gradient of the line and then determine the equation of the line. So I want you now to go ahead, calculate the gradient of the line, determine the equation of the line. This was the line. Let me redraw it again. Pause the video, find the gradient of that line, then write down the equation of that line. Alright, let's go through it together. You'd have paused. The gradient, remember, is y2 minus y1 over x2 minus x1. So this y value, remember, is negative 2. This y value is positive 4. Right? So remember, this is the point 5, negative 2. This is the point 0, 4. So y2 minus 2 minus 4 over x2, 5 minus 0. That is negative 6 over 5. That's the gradient. So the equation of the line is y is equal to the gradient. Remember, y is mx plus c. Y equal mx plus c. So this is y equal negative 6 over 5x plus c, and c is 4. The y-intercept is 4. That's it. Easy, easy, easy. Nice. Okay, another question. It doesn't look too good in the PDF, so we're going to go back to the PowerPoint to do that one. It says the equation of a line is 5x minus 2y equal 9. Write the equation of the line in the form y equal mx plus c. Hence state the gradient of the line. Then it says a point N which has coordinate h lies on the line. Find the value of h. Then find the equation of the line through 0, 2 perpendicular to L. Go ahead, pause the video, answer this question for me. Do part 1, part 2, part 3, and part 4. Pause the video, attempt it. So in doing this question now, in part 1, right, the first thing is to find the equation of this line and to write it in standard form. So first thing, make y the subject, right? Y need to be the subject. So if we bring it over, this is saying negative 2y is equal to 9 minus 5x. We can then divide both sides by negative 2. So if we go ahead, we feel free to divide both sides by negative 2. In that case, we get y is equal to 9 divided by negative 2. Then we have minus 5x over negative 2. Negative divided by negative become plus 5 over 2x. Putting it in standard form, y is equal to 5 over 2x. Then we have minus 9 over 2. So what's the gradient? Hence state the gradient. The gradient is 9 over 2. So part 2, the gradient is equal to 5 over 2. Sorry, remember the gradient is m. The gradient is m. 5 over 2. So the gradient is 5 over 2. Remember, y equal mx plus c. So that's the gradient. Now part 3. Part 3 seems like it gone tricky, don't? It says n has coordinates h, h. So what are they telling us? They're telling us that x value is h and the y value is h. Find the value of h. So if x is h, we can use the original equation and put x as h and y as h. 5h minus 2h equal 9. 3h equal 9. And so h is equal to 3. That's the answer. So that's the point. The point then, n is just the point 3, 3, and h is 3. Easy. Now it says find the equation of the line through 0 through passing through 0 2 perpendicular to L. So the next part, so if you have, let's call this line L2, right? So if L2 is perpendicular to L, what do we know? With L, remember we said the gradient was 6 over 5. So in that case, we can say the gradient of L2 is minus 1 over the gradient of L. So it's minus 1 over 6 over 5, which is negative 5 over 6. And then now the equation of a line is y equal mx plus c, right? Now they give us this point on the line L2. So when y is 2, the gradient is negative 5 over 6, the x value is 0, and c we need to find. But in that case, c is just 2. So in that case now, find, so part 4 we can label it, y is equal to negative 5 over 6x plus 2. This is your answer. That's if you're giving them in standard form. You could give them in the general form by multiplying through by 6 and write 6y is minus 5x plus 12. Then bring the 5x to the other side to say 5x plus 6y is equal to 12. If you wanted to give them it in that form, that is also fine. It really does not matter. That is it. Was it 6 over 5? Let me just go back. Oh, guys, I don't know why I'm making so much mistake today. The gradient was 5 over 2. So I was supposed to divide by 5 over 2. See, I'm making so much mistake today. 5 over 2. And I'm not even editing out those mistakes. I might edit a little bit, but this should be minus 2 over 5. Oh boy. I wrote the wrong thing. So 2 over 5. So then it doesn't change much. It doesn't change the answer much, guys, for part 4. So in that case, y is just minus 2 over 5x plus 2 multiplied through by 5. That's 5y equal negative 2x plus 5 2 is 10. So negative 2x come to the other side is 2x plus 5y equal to 10. Now you're wondering, how did I know that I made a mistake? I knew I made a mistake and I'm really happy I made that mistake. One thing I've observed with perpendicular lines, usually when they're in general form, they have the same number, it's just that the coefficient, one of the sign alternates. So the gradient would be one is 3 over 2, one's negative 2 over 3, yes. So like this, right? And how am I able to, deduce this? It's just something I've observed. So when I realized that I had the 6x, I knew that I was supposed to have 5 and 2 and 2 and 5 again. So that's how I knew that, something was off with the solution. But this is our answer. That's the most important thing. 2x plus 5y equal 10. That's what matters most. Another question. It says the coordinates of A and B are 3, 1 and minus 1, 3. It says find the gradient of the line AB. State the midpoint of the line connecting A to B, then hence determine the equation of the perpendicular bisector. Go ahead, take 5 minutes, pause the video and do that question for me, please. So in doing this question, we need the gradient of the line AB. Remember, gradient is y2 minus y1 over x2 minus x1. So y2, 3 minus y1 over x2 minus x1. So in that case, that's 2 over negative 4 is minus a half. That's the gradient, negative a half. It says state the coordinates of the midpoint connecting A to B. So that's part 1. No, the midpoint, part 2. The midpoint of AB is just average of the x, 3 plus negative 1 divided by 2, comma, average of the y, 1 plus 3 divided by 2. So the midpoint of the line AB is going to be 3 minus 1 is 2, 2 divided by 2 is 1, 1 plus 3 is 4, 4 divided by 2 is 2. So this is 1, 2. That's it. Then now part 3 says hence determine the equation of the perpendicular bisector AB. So part 3, we need to determine the equation of the perpendicular bisector. So to determine the equation of the perpendicular bisector, you have to imagine what is happening. I love when you imagine it. Remember, you have the points A and B, and then you have the perpendicular bisector. That's the line that cut it in half. This is the bisector line. Let's call the bisector line LB. So now the bisector line is perpendicular to AB. So what do we know then? What we do know is that the gradient of AB multiplied by the gradient of the bisector line, that's equal to negative 1. And so the gradient of the bisector line is negative 1 over the gradient of AB. In that case, it's going to be negative 1 over the gradient of AB was negative a half. So we divide that, we get positive 2. Now, once we get the gradient, we also need to remember that the bisector passes through the midpoint. The bisector goes through the midpoint, and the midpoint we got was 1, 2. So now we can find the equation of the line. So remember, the equation of the line is now y minus the y value at the point, or you can use y equal mx plus c, doesn't matter. The y value is 2 equal the gradient, 2 times the x value is 1, plus c, bring it over, 2 minus 2 is 0, so c is equal to 0. So therefore y is just equal to 2x. That's the equation of the perpendicular bisector. That's it. Nice. This question now. Just checking how much more questions to go. We have about 3 more questions to go. This one. A quadrilateral ABCD is formed by joining the points whose coordinates are negative 2, 0, B which is 0, 4, C which is 7, 3, D which is 3 minus 5. It says calculate the length AC, show that BD is perpendicular to AC, then prove that ABCD is a trapezium. Pause the video and answer this question. Please take 5 minutes and do it. Alright, so to do this question, let's go. Ready, let's go. So first we need to find out the length of AC. So AC, remember the length of a line is what? The square root of x2 minus x1 square plus y2 minus y1 square. So the length of AC then is going to be the square root of, where is A and where is C? This is A and this is C. So it is x2 minus x1, so negative 2 minus 7 square plus y2 minus y1 square. So the length of AC is just equal to the square root of negative 2 minus 7 is negative 9, so that's negative 9 square plus negative 3 square. 9 square is 81 plus 3 square is 9, square root of 90. No, square root of 90, I don't know. No, I'm lying. I do know. I can guess. Let me give you a guess. Square root of 90 should be 9 point. I'm going with 9.4. So here it is, square root 90. Yep, 9.486. So my guess was very accurate, right? So this is 9.48. Alright, so that's it, 9.48. That's the length of AC. Now the next part is show that BD is perpendicular to AC. Now in coordinate geometry, how are we going to show that they are perpendicular? If they're perpendicular, so part 2, if BD is perpendicular to AC, then what do we know? Then we know that the gradient of BD times the gradient of AC should be negative 1. So let's go ahead and show that. So the gradient of BD is equal to y2 minus y1, negative 5 minus 4 over x2 minus x1. So that is negative 9 over 3, which is negative 3. Now the gradient of AC is y2 minus y1 over x2 minus x1, which is 3 over 9, which is 1 over 3. Now when we multiply them, negative 3 times 1 over 3, that's negative 1. Since the product of their gradient is negative 1, hence we can tell them BD is perpendicular to AC. That's part 2. Part 2 done and dusted right there. Easy. So this is part 2. Nice. Now it says we need to prove that ABCD is a trapezium. So to do part 3, I always like when you have a pictorial representation in your mind, right? Please have a pictorial representation. What do you know about a trapezium? A trapezium have what? This is a trapezium. It have two pair of parallel sides. This is how a trapezium would typically look, right? So this is our trapezium, right? This is how a trapezium look. How are we going to show that this is a trapezium? So we need to show that there are two sides that are parallel, and then we have our perpendicular line already. So BD will show that BD is perpendicular to AC, right? So if BD is perpendicular to AC, we know one of them, I'm just writing something. We know that one side is perpendicular, right? Oh, trapezium could also look like this, right? So if we know that one side, let's say this is AC and this is BD, I'm just speculating. If this is what we have, then we know that there's another side, right? So we know that there should be another side that is going to be what? Parallel to the side at the top, right? That is all. So what we need to then show is that the next side is parallel. That is all. So what I will do to do this question is I love to get a good schematic of what's happening. So I like to have a good schematic. Right, the schematic doesn't matter. B is the point 0, 4. 0, 4 is right here. This is B, right? Then D is the point 3, negative 5. 3, negative 5 is somewhere down here. That's D. A is the point negative 2, 0. Negative 2, 0 is somewhere here. This is A. That's A, B, D, and I need C now. C is the point 7, 3. So 7 and 3 would be somewhere, maybe here. That's it. Why am I doing this? I like to get an idea of what's happening, right? And so this should be our trapezium. I know it doesn't look like a trapezium, but remember it's a sketch, right? So remember, what did we just show a while ago? We just showed that BD was perpendicular to AC. So we just showed that BD, this, was perpendicular to this. Using dotted lines. Alright, just follow what I'm gonna do. I love to have clarity in what I'm saying, right? So just for clarity, I want you to see what I'm doing, alright? So just follow what I'm doing, please. Look what I'm doing. I'm plotting these points. The points I'm plotting are negative 2, 0, 0, 4, 7, 3, and 3 minus 5. Negative 2, 0 for A. Plot that point negative 2, 0. Then I'm plotting the point 0, 4. It's always better when I do these questions where we can actually see the graph, right? Then now we have 7, 3, and then 3 minus 5. So 7, 3, and then 3, negative 5. So those are the 4 points that we have, alright? These are the 4 points that we have, and I'm going to label them now A, B, C, D. So this is A, B, C, and D. Now that we have our points labeled, right, if we connect them, this is what we have. It's always best when you're going to see it like this. Trust me, you're going to see what is happening now. Trust me. If this is what you have, I hope everybody see the trapezium now. This is the trapezium. Now, if this is a trapezium, how would you go about showing that this is a trapezium? This is a trapezium if what should happen? If AB is parallel to DC. That's the first thing. A trapezium have what? Pair of parallel sides, right? So this side must be parallel to this side. Now, if they're parallel, what do we know? Then their gradient should be equal. So that means the gradient of AB should be equal to the gradient of DC. Let's go ahead and prove it. That's all we're really required to prove, right? That the gradient of AB is equal to the gradient of DC. That's how we're going to show it's a trapezium. See here? It have a pair of parallel sides. So now let's go ahead and do that. So to show it is a trapezium, so for part 3, we're required to now prove that the gradient of AB is equal to the gradient of DC. Now the gradient of AB is y2 minus y1 over x2, y2 minus y1 over x2 minus x1, that's positive 2. Then the gradient of DC is y2 minus y1, negative 5 minus 3 over x2 minus x1, which is negative 8 over negative 4, which is positive 2. Since the gradients are the same, therefore AB is parallel to DC. Now, since it only have one pair of parallel sides, remember when I look back at our sketch, these were the only sides that were parallel. The next two sides weren't parallel, so it's just a trapezium. So it's not, remember this showed you. So since it have one pair of parallel side, Hence, it's a quadrilateral. Hence, it is a trapezium. That is it. If it had two pair of parallel sides, it would be a parallelogram. But it didn't have two. It just have one pair of parallel sides. Nice. Question 6 now. Pause the video and do this question. It says the diagram above shows 2 points A and B. Calculate the gradient of AB. Determine the equation of the line AB. Then hence state the value of K. And then now obtain the value of X that lies on the line AB. Pause the video, answer this question. Alright, let's go through this question now. Okay, this is the last question. So they didn't give us enough space to do this question, or I didn't give enough space, no problem. Find the gradient. Now the gradient of AB, remember, is y2 minus y1, so 2 minus 7 over x2 minus x1. That's negative 5 over 3 minus 6 is negative 3. The gradient is positive 5 over 3. Determine the equation of the line. Determine the equation of the line, right? First thing is, since we have the point A, which is 6, 7, right? We have the point A, which is 6, 7. Remember, the equation of the line is y. The equation of the line, remember, is y minus the y value at that point 7 equal the gradient 5 over 3 in bracket x minus the x value at that point. So from that now, we can now, go ahead and make y the subject. So y is equal to 5 over 3x. Then 5 over 3 times minus 6. 5 times 6 is 30. 30 over 3 is 10, so that's minus 10. Then we'll add 7 to both sides. When we add that 7 to both sides, it works out to be y is equal to 5 over 3x minus 10 plus 7 is minus 3. That's it. Now hence state the value of k. K then is what? Negative 3, because we got it in the form y equal mx plus c. Remember, y is equal to mx plus c, and c is what? K. So in that case, our k is negative 3. K is equal to negative 3. Easy. Now the last part says, obtain the value of x. We need to obtain the value of x if a point x negative 6 lies on AB. So when the x value is negative 6, so negative 6 is somewhere over here, we need to find the corresponding, oh sorry, the y value is negative 6. See, I'm doing rubbish. The y value is negative 6, so the y value is somewhere here, negative 6. We need to find the corresponding x value, right? That's what we need to find. No problem. So to do that, we're going to use the equation of the line. So remember the equation of the line we generated now. The equation of the line we generated is y is equal to 5 over 3x minus 3. So if the y value is negative 6, and negative 6 is 5 over 3x minus 3. Now solve for x. Add 3 to both sides. Minus 6 plus 3 is equal to 5 over 3x. Remember, this is the last part we're doing. Let's call it D. Then now, negative 6 plus 3 is now negative 3. That's 5x over 3. Cross multiply. That's negative 9 is 5x. We divide by 5 to get x is negative 9 over 5. That's our answer. X is negative 9 over 5. And that wraps up coordinate geometry. We did all the different ways the question can be worded. Now, you want more questions? No problem. Check out my website, alright? Remember, it's continuously being updated. It's a new website, so just check out the website.